create different tools from Create menu. You can find categories, and let's create one dot plot and histogram, for instance. You can select them, resize them, move them, and by clicking Shift button you can make a multiple selection. Let's click that one, and for selected tools you can load the data like this. Let's load different data, and then you can reload some new data, or there are shortcuts for jumping next and previous file in directory. When you right click the tool area, you can find the pop-up menu showing different actions and features, and different tools have different pop-up menus. And also, if you have access in the tool, for instance these two have this access, then right clicking the axis name you can select which parameter you would like to see. If you have just one tool selected, then tool properties is also available. You can for instance affect here in histogram the line color and font sizes, and whether you would like to, for example, see the file name or not, like this. And then if you need more information about this tool, then select this and go to help and find online help for selected tool. It will open the online video, and it will show all the important features of that specific tool. You can find also the same videos from flowingsoftware.com, and in documentation there is object specific help, and all the videos are available also there. There are two types of regions. For dot plots there are polygon regions, and for histograms there are one-dimensional histogram regions. Let's create one polygon region. By right-clicking you can create new region, and then start clicking here. Let's mark the lymphocytes, and then the population appears here. By right-clicking here you can rename it, for example, or change the color, make it transparent, or even delete it. And then if you want to see only lymphocytes here and here, then right click again and show populations. Then you can select that show only lymphocytes. As you can see, this dot plot and this histogram, they have the same file. However, this histogram has the different file loaded, but still you can use the same gate, and that's because this system calculates who belongs to this region for every file in memory. So that makes it more flexible. You don't have to gate every file separately. You just make one gate, and it can be applied to all files. And then if I create new region here, I can make the region for positive cells. And if I want to see this same gate, because this and this has the same detector here, if I want to see this H2 here also, I can go here and click and show regions. Here are all regions listed who have the same detector here. So if I put like this, you can see the same. If I move it here, it is also moved here. The tools can be connected. Let's create one dot plot, and if I want to visualize the same data file I have here, of course I can go here and open FCS, but the other way is to create the connection between these. And here is the connection area, this red one. I hold left mouse button here, down, and go here and release the button. And the connection is established. Here I have so-called master, and here I have servant. Every time when master is updated, for example, I go to the next file in directory, it forces this to load the same file. So by this way you can make even long paths of tools, and every time when the master is updated, then the servants will be updated. If I update this, for instance, jump next file, this is not updated because the command doesn't go that way, only that way. Normally you must first create the tool and then make a connection like this. But then some tools, such as statistics, must be created via pop-up menu. Right click here and create statistics. This is the way to create statistics, and here we can see the strong connection. Strong connection is because the statistics is nothing without its master. Normally, if I delete this or this, then the tool is just simply deleted and connection is lost. But here, if I delete this tool, then also statistics is deleted. If I delete now, they both disappear. This connection, if you want to get rid of connection, you just right click here and delete connection. Here I have the living cell gate, and then another gate having fits positive PE negative population. And I would like to know how much there are APC positive cells. And problem is that I would like to select these both. I want both living cells and this fits positive PE negative, but I cannot select these both at the same time. That's why I must combine these two populations, and the combination can be done exactly with the same logic as combining the tools. Push left mouse button down here and release it here. It asks what to do. I want intersection, so now I have new population R1 and R2, and then that can be selected here. So now when I create new region, I get information about live fits positive PE negative APC positive population. There are several tools for collecting the data. First, statistical information. Let's create statistics, and from statistics tool you can create stat list. Now we have all these numbers here, and for example we are interested of collecting percent of positive and the mean value of those positive cells. Then by right clicking stat list we can select positive percent of this and for instance the mean. Now when I jump to the next file, jump to the next file, jump to the next file, you can see that it collects all the files and only those numbers I have selected. And this can be copy-pasted to, for example, Excel for reporting. And then this can be also visualized as 96-well. 96-well mode, you cannot show no more than one number, but nothing prevents you to create several stat lists. That here we can select mean and show as 96-well mode. They are here. And this 96-well mode works only if the data file contains the information from which well it has been run. So sometimes you might need the images, that where the data comes from. And in collection tools you can find image collector, and let's connect it here like this. And now when I start to jump forward, next, 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 you can see that those images are collected here. If I reshape this, then these are automatically reorganized, so they are all safe here. And then let's delete this, and if this data has been run from WellPlate, this collection can be done also in WellPlate format. And now the image is located into the correct well. If I jump now forward, it will be in the correct position. And this is now a huge image, but then you can also you can copy paste it for further reporting. Let's delete that. And then next statistical tool, collection tool, is called token. This is a little bit different. This is just a value holder. Itself it's very boring, but it has several benefits. You can select quite similarly as in StatList. You can select number, but only one number. It holds only one number, and when the file is changing, it just holds the one number from one file. Boring. But when combining with other tools, it's quite powerful. Let's create other statistics from here, and this percent of leave is now interesting. By the way, you can a little bit clean statistics like this by hiding the unnecessary numbers, and then create other token, and now leave percent of this is interesting. Tokens can be used with collector list. It's quite similar to StatList tool, but it can take numbers from different statistics. If I combine them here, then it will collect numbers from all tokens. And if I now jump forward and forward and forward, this is the way to use tokens for collecting numbers from different statistics. Of course, you can have many tokens from one statistics, and they can be then collected here. Overlay histogram is one of the most efficient tools for visualizing differences of two samples. In Flowin software, you can create overlay histogram, but you cannot load data file directly to overlay histogram. Instead, you combine different histograms. For instance, I have histogram 1 and 2 here, and when I combine these into overlay histogram, the data can be seen directly here. And the idea is that whatever happens here in the masters, it will be reflected to servant. So, for example, if I jump to the next file in directory, it is reflected here. If I create here new region like this, it can be seen here. When you have a high number of samples, maybe you would like to automate the analysis. Here the living cells are gated, then positive cells are here, and from statistics the percent of positive cells will be collected into the stat list. Of course, I could jump here, next file in directory, so many times that I can fill the whole well plate, but the other way is to use automation tools. Folder runner is very easy to use. You just load the first one and connect it to here, and then we can find feature run through current folder. Now when I start running, it goes through all the files in the folder and updates this, which updates this, which updates this, which updates this, and this happens until it reaches the end of the folder, and data is here. The automation tools can be chained to make this automation more efficient. For instance, here I would like to have the pairwise overlay histograms. For instance, here always the A1, and here, for example, A2, something like this. And then next pair would be A3 versus A4, and so on. How to automate this? In automation tools, you can find different tools for this purpose. For example, Forward Jumper is very nice tool. You can combine it with Folder Runner and make it so that it's always jumps one forward. When the master updates it, then its file increment is 1, so it's always 1 ahead. That can be connected to here, like this, and here the file increment can be put to 2. So this jumps every second, and then this is always 1 forward. Let's run through current folder, see what happens, and the result is this. We have A1, A2, A3, A4, A5, A6, B1, B2, and so on. So looks like that it made what was meant to be. So other way of using these are, for example, you might have some condition. For example, you have in column 1 you have always negative sample, so you can make the automation tool which updates only when column is 1. Of course, this assumes that you have run yourselves from well plate. And let's clear this. And now this should be that this overlay histogram is always the sample, and then as a background, this gray background, there is always the sample from column 1, and file increment is 1. So let's check what happens. You can see it always keeps the sample from column 1 as a background, and then when we jump to the next column, it updates it. And C, and the D, and so on. And then you can also make it so that it updates only, for example, every third sample, or when the file name contains, for example, negative or something. Sometimes you may want to make some modifications to the files. Category data manipulation tools contain different tools for that purpose. For instance, you would like to analyze only, for example, 5,000 cells from the sample. Event number reducer can be used for that. First, connect these two, and then file is here and show number of events. Let's define the number 5,000. And now when I connect these, now you can see that this contains only 5000. But the point is that here the master still contain all events. So the idea is that whenever file goes through this, this will create a new instance from that file, make the modification, and then sends it forward. So this original file remain here unaffected. Anyway, by the way, the original data files will remain unaffected, but this also you can use these files still before change and after change. This is the tool which makes the new instance of the file. And then let's, for example, change parameter names. Let's disconnect these and make some modifications. Here I can edit modifications, and right clicking, let's forward scatter will be cell size, and side scatter will be granularity, and save modifications. Now every time when file goes through this, again new file instance will be created into the memory, and then it goes through all the parameters, and if it finds, for example, this FSC A, it will change it to cell size. If it's not found, then nothing happens. And then here we have the list which will be changed and then sent forward. Here we have still FSC and SSC, but when the file goes through this, then suddenly this has been changed. I have staining here CD3 versus CD19 and the percentage values here, and then secondary control having some unspecific binding in FL2 channel. And I would like to subtract this number from this to get the real value for CD19 positive cells. And in statistical tools I can find calculator. Calculator can be used like this. I can define formula. It can be anything. 5 times 5 is 25. Yes, that's good. But also we can use here in the formula, we can use these numbers. Not directly, we need first token. Let's create token and define it that it shows this left top percent of this value. And here the same. Like this. These both can be connected to calculator like this. And then we can define formula that we want to subtract this from this. So that means that in instructions it tells us how to refer to token. Token 8 minus token 7. This is token 8, this is token 7. Token 8 minus token 7. Okay, and now we have result. Before continuing, we must define which one is so-called master token, because this accepts now two different tokens and they have different files. So that's why we must define which token tells which file we have. And of course we want that because this is the real sample and this is just helping us for defining what is the background. So master token is this token 8, and then we can create stat list. It will tell that in this file the result of this calculation is here. Sometimes you might need to calculate something cell by cell. For example, in this case, in this Phred sample, Phred divided by donor, cell by cell. so you must know the new value for every cell. Create statistical tool and cell calculator is tool for that one. Let's combine these and make the formula. This formula can have token values but also channel names. We can here define threat divided by donor times 100 if you want. You can add anything as any formula. And now it calculated the new parameter. If we connect it to dotplot, then we can find the calculated parameter, and now we cannot see anything because parameter max is 1000. Let's make it automatic, and now it's from 0 to 2, and visualization is lean. So you can create a brand new parameter and rename it and get new values and, for instance, calculate statistics. Sometimes you might have a challenge with, for example, intracellular stainings, where the populations don't stay in constant place, but they all the time are moving to left and right. And for these kind of situations, there are tools in Flowing software, and in region control tools you can find, for example, move regions over negative and positive populations. This assumes that you have two populations, negative and positive. Now I connect it here, and when I activate the control, now it took control over these two populations and calculated the threshold between negative and positive populations and put the gate according to that. And if I jump to the next file in directory, you can see that also the gates are moving. So this is the way to automate the analysis. This is not super intelligent and not perfect, but at least it helps you to automate your analysis, and maybe then you can check later and correct those cases, maybe rare cases, where this algorithm has failed. But anyway, this is if you have hundreds of even thousands of samples, this is hopefully very big aid for your analysis. Similar situation might be in cell cycle analysis, where sometimes staining intensity changes and the peaks are in a little bit different places. I can create cell cycle tool. This is meant for 3 populations, and there are a couple of variables, and when I activate this control, it moves this G1 to the G1 peak and then S phase, and it tries to calculate where G2 peak should be. If I jump to the next file, then it tries its best to follow. But this is hopefully some kind of aid for bigger amount of samples where you have challenge for with the moving populations.